The universe is not just vast, it is ancient, and it does not exist in the present moment. Not for us. Every star you see, every galaxy you photograph, every flicker of light from the edge of existence is not what it is now. It is what it was, long ago, far away. When you look up at the night sky, you are not seeing space. You're seeing time. Each point of light is a memory, a whisper from the past. The farther away something is, the older its image becomes. Light travels fast, 300,000 kilometers per second. But even that speed is too slow to carry truth across the cosmic distances. We do not live in the now. We live in the echo, and what we call reality. It's just the fading imprint of events that ended long before we were born. Even right now, as you sit here reading this, you're not seeing the world as it is. You're seeing it as it was, a fraction of a second ago. If your friend stands 1 meter away, the light reflecting off their face takes just 3.33 billionths of a second to reach your eyes. That's not noticeable, not measurable by human senses, but it's there. You're always seeing the past. Always. The brain compensates. It predicts. It fills in gaps. It makes you believe you're seeing the present. But physics doesn't lie. There's no now, only delay. And when the distance grows, so does the lag, until it becomes impossible to ignore. The moon orbits Earth at 384,000 kilometers. Light needs 1.28 seconds to cross that gap. So when you look at the moon, you're not seeing the moon as it is. You're seeing it as it was 1.28 seconds ago. If someone on the moon lit a flare, you wouldn't see it until over a second later. If they shouted, you'd hear them after that same delay. Communication with lunar astronauts isn't live. It's delayed. Every word spoken, every command given, every heartbeat monitored arrives late. And if something went wrong, you wouldn't know for more than a full second. In space, a second is an eternity. In human terms, it's nothing. But in cosmic terms, it's the difference between life and death. The sun is 150 million kilometers from Earth. Light takes 8 minutes and 20 seconds to travel that distance. So when you feel the warmth of sunlight on your skin, you're feeling energy that left the sun's surface 8 minutes ago. If the sun suddenly vanished, you wouldn't know for 8 minutes and 20 seconds. The sky would stay bright. The air would stay warm. Birds would keep flying. Life would go on, unaware. Then, in perfect silence, darkness would fall. No warning, no sound, just gone. And we've known this for centuries. Every solar flare, every sunspot, every coronal mass ejection, we observe it only after it has already happened. We watch the sun through a window that opens 8 minutes late. Mars is our closest planetary neighbor. At its nearest, it's about 55 million kilometers away. At its farthest, over 400 million. On average, light takes 14 minutes to cross the void between us. That means any signal sent from Earth to a rover on Mars takes 14 minutes to arrive. Any response takes another 14 minutes to return. A simple question, "Are you still working?" requires 28 minutes for a reply. NASA engineers don't control rovers in real time. They send commands like letters. Then they wait, hours, days, for the answer. When Perseverance landed, the entire team watched screens in silence. They didn't see the landing. They saw the record of it. From 14 minutes earlier, the dust had settled. The parachutes had detached. The sky crane had fired its rockets, all before anyone on Earth could even blink. We don't explore Mars. We excavate its past. Pluto is not a planet anymore, but it's still a monument to distance. At its closest approach, it's 4.67 billion kilometers from Earth. Light takes 4 hours and 36 minutes to make the journey. When New Horizons flew past Pluto in 2015, it sent back images, slowly, 1 pixel at a time. Each photo took over 4 hours to reach us. We didn't watch the flyby. We waited for days, for weeks, to receive the data. The spacecraft had seen Pluto. We only saw it later. And when we did, we realized we were looking at a world frozen in time. A relic from the birth of the solar system. A place where the sun's light arrived nearly 5 hours late. What we saw wasn't Pluto today. It was Pluto from 5 hours ago. And in that delay, we found beauty. The closest star to our sun is Proxima Centauri, just 4.24 light years away. That means the light reaching your eyes tonight left that star over 4 years ago. If a massive explosion occurred on Proxima Centauri tomorrow, we wouldn't know for 4 years. We wouldn't see the flash. We wouldn't feel the radiation. We wouldn't even know it happened until 2029. Right now, the light arriving at Earth from Proxima Centauri was emitted in early 2020. That was the year of the pandemic, of lockdowns, of people staring out windows. And somewhere, in the silent red glow of that distant star, the light from those moments is still traveling. We don't know what happened there. We won't know for years. And by the time we do, the starscape will have changed again. Our home galaxy, the Milky Way, stretches 100,000 light years across, and we stand near its edge. The center, where the supermassive black hole Sagittarius A* resides, is 25,000 light years away. So everything we see in the galactic core, the swirling gas clouds, the dense star clusters, the violent explosions, happened 25 millennia ago. That's older than the pyramids, older than written language, older than agriculture. When that light began its journey, humans were still hunter-gatherers. Ice sheets covered Europe. Woolly mammoths roamed the plains. And now, we stare into that ancient fire. We call it science, but it's archaeology. We're digging through layers of time, not soil but photons, trying to understand a world that died long before we evolved. The pillars of creation, those towering columns of gas and dust in the Eagle Nebula, are among the most photographed objects in astronomy. They glow with the light of newborn stars. They look eternal, but they are not. Scientists believe that over 7,000 years ago, a supernova exploded nearby. The shockwave tore through those pillars, destroyed them, turned them to dust. But the light from that destruction hasn't reached us yet. So for now, we still see them, whole, beautiful, alive, as if nothing happened. We are watching ghosts, objects that ceased to exist thousands of years ago, and we still admire them as if they're real. We are not observers. We are historians, looking at ruins without knowing they've been gone for millennia. Andromeda, our nearest galactic neighbor, is 2.5 million light years away. The light you see tonight left Andromeda 2.5 million years ago. That's before Homo habilis walked upright, before stone tools, before fire was mastered, before we had names for anything. At that moment, Earth was ruled by giant mammals. The climate was warmer, forests spread, and somewhere, deep in the spiral arms of Andromeda, light was escaping from stars that may no longer exist. Perhaps a civilization there looked up at their own sky and saw our Milky Way as a faint smudge. Maybe they wondered if anyone lived there. Maybe they built telescopes. Maybe they tried to listen. And maybe, just maybe, they received our first radio signals. The ones we started broadcasting 100 years ago. But those signals haven't reached Andromeda yet. They're still traveling, still climbing, still waiting. And when they finally arrive, 2.5 million years from now, the descendants of whoever was there then might look down and say, "Look, they were here. Once, we think we see the universe, but we don't. We see its shadows, its echoes, its memories. Every photon that hits your eye is a message from a dead moment, a ghost from another age. The stars you admire, they may be gone. The planets you dream of, their skies may have collapsed. The civilizations you imagine, they may have risen and fallen while you are still learning to speak. Time doesn't flow evenly. It stretches, it bends, it lingers. And the deeper you look, the further back you travel. You are not standing still. You are drifting backward through layers of time, pulled by the speed of light. And if there is life out there watching us, they're not seeing you as you are now. They're seeing you as you were millions of years ago. Maybe they see dinosaurs walking the earth. Maybe they see forests growing where cities now stand. Maybe they see the first fire lit by a human hand and wonder what kind of creature could create such a thing. We are not alone in the universe. We're just very, very late. And the universe, patient, silent, endless, waits for us to catch up. We hope this journey ignited your curiosity. Stay with us as we explore how time itself becomes a landscape and how every glance into the dark is a step into history. Subscribe and join us for the next discovery.